think we should start now. Welcome back to sir, Dr. Rajesh Doriya sir. So, sir will take session on introduction to ROS and web, uh, web Webots simulation tool with hands-on session on ROS. So, sir, you can start your session now.
Okay, sir. Thank you, sir. Thank you so much. So I'm expecting that all the attendees were present in the first session, because in the first session I have covered quite quite a lot about ROS. So so I guess all of you can see the screen, right? Sir, can you see the screen? I'll share the screen now.
Yes, sir, we can see you, sir, your screen.
Okay. So guys, if you remember that we have discussed few slides regarding robot operating system. So So if you recall, in the first session, I have told you what exactly we mean by robot operating system. So just to remind you once again, because before moving further into the implementation part, we must have to understand the philosophy of robot operating system. So just to recall, if you remember that robot operating system is an open source meta operating system especially designed for the robots. Okay, and it provides number of functionalities. For example, hardware abstraction. So whatever hardware we have got and whatever data we have got, so if in case if you want to deal with the hardware, if you want to communicate with the hardware, if you want to communicate with the robotic hardware, then it is going to provide the hardware abstraction. Means you can make the use of robot or operating system in order to talk to the robotic hardware. So this is where this comes into picture, and it is also going to provide you the low level device control. So it is going to help us a lot in order to communicate or control the robotic hardware. And apart from that, it also implements mostly commonly used functionalities with it. So we'll discuss this one. And there are number of processes, of course, number of nodes are there, and all those nodes are nothing but the processes. If you talk about in terms of operating system, then we deal in terms of processes. But in case of robot operating system, all the processes are generally being dealt in the form of nodes. And it has got a package management system. So whatever messages, nodes, and topics we have got, all those things are going to be managed in the form of a package. So it has got a packaging system, so one can create their package, one can add some other packages, and then they can create their own environment. Okay, so in short, they have got a package management system. And it also provides number of tools and libraries for obtaining, building, writing, and running code across multiple computers. So it may be possible that we may want to create an application across multiple systems or multiple robots. So it does provide that capability where a sharing, or you can say network application, can be built. So where number of robots are going to be there and they can collaborate in order to accomplish any task. Okay, and as mentioned earlier, it does follow a publisher subscriber model for message communication. So this is how the packaging system of ROS looks like, which have been already discussed. So we can say, we can see number of stacks are there, which makes a repository, and in each and every stack we have got number of packages, right? And for each packages consist of nodes, messages, and services. So again, in brief, we can say ROS is a meta OS for robot. It is free and open source. So this is the most important point regarding robot operating system, that it is free and open source, so one can play around its code. So that is a very beautiful thing. And then there are a number of programming languages which are being supported by the ROS. So C++, C, Python, Lisp are few of them. And as mentioned, it supports the packaging system. And these are some of the robots which are being supported by the robot operating system. So this is how the things work in robot operating system. So we have got number of nodes, and all those nodes communicate together with the help of a central unit named as ROS code, right? And then as discussed earlier, we have got a publish subscribe model in robot operating system. Publish means whenever some data is getting created, so all that data is being transferred with the help of a message. So the number of nodes which are interested in that particular message type are going to subscribe on that topic. So the moment any new message gets published, all the subscribers node are going to get that data. So this is the basic philosophy of robot operating system mechanism. Now this one also, we have got number of nodes. So if we are going for a service, in that case we are going to make a request, then we are going to get a response, right? And on a given topic, if some nodes are interested on that topic, then if some messages are being published, then those messages are going to be passed to the subscribed nodes. So this is the fundamental working of the robot operating system. Now I would like to play one video for this one so that you can know the working of robot. Just hold on. So as you would have seen, almost every type of robot has been covered by robot operating system, right? So its adaptability is huge in robotic research. So you guys can very well think of adopting this particular tool. So to begin with, towards the implementation part, if we talk about the distributions of robot operating system, then there are number of distributions which you can use. So it all started way back in 2010, and the first distribution of ROS which was introduced was your ROS box turtle. Then ROS C turtle came into picture, then Diamondback electric. So these were some initial ROS distributions, and in this series some other distributions also came into picture like Fuerte, Ruby, Hydro, then Indigo, Z, Kinetic, Lunar, and recently we have Melodic and Noetic. So in this lecture I am going to demonstrate some of the functionalities of robot operating system with the help of this kinetic version of robot operating system. So these are some of the distributions, and if you have looked carefully, then it is something like the Android versions. It started with P, then C, D, E. So like that, they have also followed the same alphabetical uh, system. So these are the some of the distributions of ROS. Then now the point is how we can start working with robot operating system. So to do that, they have created a web page for this one. That is www.ros.org. So the moment you log on to this particular web page, you will be landing on this page. So you can see the some of the things like which one is the current version, okay, and which one is the version providing the long-term support, and there what is they will be describing about themselves, then why, what is the importance of robot operating system. Then if you want to get started with robot operating system, then you can follow this particular link. So like this you will be finding in the landing page. So if you want to start, then you should follow this particular link, getting started, and the moment you will click on that one, you will be landing on this page. So number of ROS distributions will be there at the front of you. So it is up to you which one you like, and of course each and every distribution has going to a different number of features. So it is up to you what sort of application you are interested to work upon. So these are some of the things. Then if we talk about the installation of one of the distributions, which I'm going to address shortly. So in order to install ROS distribution, first we need to configure the Ubuntu repository. So after setting up the repository or the sources list, then you can move towards the ROS tutorials, and that you can find on this particular web page. Okay, so on this address. So after opening this page, you will find the tutorial like this. So you can follow these tutorials one by one, starting from the installation, then navigation of ROS file system, then building of packages and nodes and all the things. So that can be done. So as you can see in this tutorials, they have provided how to install it, how to navigate, how to create, build, understand several other topics, right? So in today's hands-on, we are going to cover some of them so that you can have some confidence at least how to start or how to install. So that depends upon your interest or research area. You can excel in this particular direction. So today we are going to do these exercises, and these are for intermediate level. And of course we have got of course they have provided some things regarding the expert level as well, where someone can create their own packages, can create their own robot URDF and other things. So that is also there. Then apart from that, I am also interested to give you the overview of another simulation tool, that is Webots, and that is also a very good simulation software, and that one is particularly designed for the mobile robots. And if you talk about what is special regarding Webot, so it is going to provide you the facility where you can create your own 3D virtual worlds with physical properties. So all the functionalities of ODE, Open Dynamic Engines, are there, and number of sensors and actuator devices can be equipped to variety of robots. So we have got variety of sensors, for example, gyro, you can use compass, touch sensor, rangefinder, even the LiDAR sensor, so even GPS. So number of almost all the sensors are there in the webboard. So it is up to your visualization that what sort of robot you want to create. So either you can create your own robot or you can use their created robot. So you can program any robot and you can test whether the robots are working properly as per your program or not. So the user can program each robot individually to exhibit a desired behavior. And if you want to get the more information, then of course they have created the web page. So you can follow this web page and you can get the information regarding this particular tool. So if we talk about how exactly we create a robot or do the things in Webot, so first we are going to model a robot. So like we are going to create a world, then we are going to put up all the physical properties for a robot. So we call it as a modeling. So after modeling a robot, then we are going to write a program for it, and thereafter we are going to run those programs for that particular design robot. So we call it as a simulation. So if this simulation is going right, means it is behaving as per our expectation, then we can transfer the real code or the code which we have written into the real robot. So that is why we all calling it as a real-time simulation software. So for example, this robot is also available in hardware. So if some standard robots are there and you have made your own program or you have created your own applications and you want to test it whether that application or research idea is working or not, so you can just simulate it in this particular software, and if that application or your idea is working fine, then you can directly transfer into the real hardware. So this is again a very good software for the robotic researcher. So if you talk about the applications of robot, then the robots is being widely used in mobile robot prototyping. It is being used in multi-agent research, adaptive behavior research, mobile robotics teaching. So these are some of the applications where the robots is being used extensively. And these are some of the snapshots of the robots which are already available in the Webots software. So IVO robot is there, pet robot is there, industrial robot is there, and robot is there, now robot is there, EPUG robot is there. So as you can see, some well-known robots are already available in the Webot software. So to tell more about robots, let me play one last video so that you can understand things regarding Webot. So in this video, you have seen almost all the types of uh, robots and the applications where they can be used, right? So it offers vast possibilities for the research. So you guys can consider this software as well for your research. And of course, but the main thing regarding this software is it is not free of cost. So one has to pay the price for it. Although you can see its source code and binary packages for free, but in order to uh, utilize in full-fledged way, one need to purchase it. So if you have got some provision or some funding with you, then it is highly recommended that you can go for with this one. And this one has been designed by EPFL Switzerland. And as in this slide, you can see the popularity of Weber. So almost all the leading institutions are using this software, including MIT. So MIT, Stanford, Boston, right, and EPFL. So these are some of the institutions or the colleges which are working on Webot software. So these are things, and these were some of the references which I have used in the morning session and in today's session. So with this, I'll just end this my presentation, and then I'll come to the that implementation part. So in case if any one of you have got any doubt, then you can note down this email ID. Anyway, I'll ask the question at the end. So I hope my screen is visible to you all. So what you guys can do, either you can start working on the Ubuntu machine itself, or you can take the help of VirtualBox. So if you guys want to work on Windows and Linux simultaneously, then you can take the help of VirtualBox to experiment on this robot operating system. So what I have done, I have installed this Oracle VirtualBox, and inside I have installed this Ubuntu 16.04.7 version of it. Okay. So I request all the participants to please open the PDF which have been shared with you, so that the participants who have installed or who are ready with the Ubuntu operating system, they can follow me with the implementation. So can either open the PDF or so you can type ROS kinetic install in the web page, then you can click on this link. So as I've been explained earlier, there are a number of distributions. So for this today's hands on, we are going to use this kinetic distribution of ROS. So you need to open a terminal. I hope the things are visible to you all. Any one participant can please reply.
It is okay, sir.
Okay, thank you. So what I have done, I have just opened a ROS page for kinetic installation, because I believe that the starting is very difficult. So if you can learn how to install it, and if you can learn how to initially work with ROS, then it is going to be very easy for you guys. So I have just opened this page, and I have also provided the same PDF. So what we are going to do, we are going to install this kinetic version, and as you can see that it is supported by Ubuntu 15.10 and Ubuntu 16.04. So I have asked all of you to install this one, okay, and the long-term support of this version. So first we need to set up these sources from where we are going to download the ROS. So to do that, we need to execute this particular command to our terminal. Okay, so I have just copy and pasted over here so that the sources can be configured. Okay, so this is how we have set up the sources list from where we are going to download all the things. Okay, then we need to provide certain keys so that all the things can be downloaded without a hurdle. So first we need to install this curl, which is again a command line tool and library to install all this script or transfer the data. So I'm going to do that. Okay. So sudo apt install curl, and then since I have already installed it, so take much time. Yeah. Okay. And then we are going to get the keys with the help of this curl command. Okay. So I have just copied and pasted this command from here to here. I hope I'm not going fast. Okay, so as you can see, now these sources have been set up. Now we are ready for the installation. Okay, so you guys can follow me on 1.4 section. So before installation, we have to make sure that whatever installation, operating system installation we have done, that is up to date. For that, we need to execute this particular command. Okay, so let me execute this one. Okay. So yesterday only I have upgraded my system. So that is why it has not taken up much time. So all of you need to execute this particular command before the installation. Okay. Now moving forward, now we have got number of options that which one to install. So either we can go for the desktop installation, which is the recommended one, because this is a full desktop and full installation. So in this we are going to get number of libraries and tools. So RQT, like RQT, RVs. So these are the tools which are going to be embedded with the full installation. So I recommend all of you to install this one. Okay. Alternatively, you can go for this one and this base installation. So depending upon the space available with you guys, so I recommend that you should go for this one. So I'll copy, then I'll paste this command over here. So this will initiate. So this is going to install the desktop full version of ROS kinetic distribution. Okay. So since I have already installed it, so that is why it has been executed very quickly. So in case if you are going for the first time, then it is going to take approximately 5 to 10 minutes. So it depends upon your internet connection. So if you got a good connection, then the things can be done faster. So you can start this installation, but by that time I'll move towards the next process. Okay, so it is going to take 5 to 10 minutes. And yeah, alternatively you can install individual packages. Okay, so rather than installing individual packages, we have done the full installation. Okay, then we need to set up the environment. So the moment we type any command for ROS, where those commands are going to be found by the operating system. So that is why we need to set up this environment. So for that, again, I'm going to copy this command and then paste over here. Okay, so it is going to paste all the environment variables in the bash RC file. Okay, so I just copy from here and pasted here. Right, and then I need to source it. Okay, so now the environmental setup has been done. But in case if you are interested in multiple distributions, then each and every time when you change the distribution, you have to source that particular distribution. Okay, for example, I have installed Diamondback or Kinetic and Lunar or some FluidTech. So in that case, which version you are interested, that you need to source each and every time. Okay, but if you are using Kinetic only, then you need to worry. And of course, let me source it once again, no problem. And if in case you are using some other shells apart from bash, for example, Z shell, then you can use this command. Okay, so I assume you installed this 16.04.7. So in this we have got by default bash shell. So this is going to work. Okay, but in case if there is a Z shell in your system, then you need to execute these two commands. Okay. Now let us move to 1.6, where we need to ensure the dependencies for building packages. So in order to install all the dependencies for building ROS packages, we need to run this command. Okay, where all the dependencies have been mentioned. So let me copy this one and paste. So this way all the dependencies are going to be installed. Since I have already installed it, so that is why quickly this command has been executed. Then all the dependencies has to be initialized. Okay, and for that to have, we need to execute this particular command. Okay, so this command has been copied and pasted, which is sudo apt install python ROS repository. So this also has been executed successfully, right? And then we need to initialize them from sudo rosdev init. So I'm going to initialize them. Okay, so sudo rosdev init. So since I have already initialized, so that is why it is asking that am I supposed to reinitialize it? So I'll leave it. Then rosdev update. Okay. So it is going to update all the sources and all the things. So this has been done. Now we are going to the tutorial part. Okay, so till this point, if all the things are being done properly, then your installation will be done properly. Okay, so if all the commands have been executed successfully, that means you installed ROS properly. So now yeah, so the installation has been done. Now we are going to manage our environment. So let us see the thing which we have installed, whether they have been installed properly or not. For that, let's print the environment. So that way we will be able to know what we have installed. So as you can see that it is going to show the information of our installation. Okay, so this is the detail of our installation. Fine. Now yeah, of course you can source it once again, but there is no need since we are already done. And then in case if you want to create your own packaging system, in that case you will need to create a ROS workspace. Okay, as I told you earlier that ROS follows the packaging system. So in order to create any new project or new system or new robot, you will be in a need of creating a package. So in ROS there is a process which you need to follow in order to create a package. So for that to have, I am telling you the process. So first you need to create a Catkin workspace. Okay. So in the first command, we are going to create the workspace. So you can just copy it. I have already done it, but anyway, I'm doing it once again. Okay. So this way, in the home folder, this particular folder and this folder will be created. Okay. So these two folders will be created. So let me show you. Yeah. So as you can see, this Catkin folder has been created. Okay. And when you will move inside this one, then again you will see that one more folder is also there, SRC folder. Okay. So these two folders will come later. Then after navigating inside the Catkin, so this you need to type this command and then you will end up inside the Catkin workspace folder. Okay. Then you need to execute the third command, Catkin make. So this is going to process the created directory. Okay, so it will make all the necessary changes which is required for the implementation. Fine. And of course the this source of level has to be done, development package. So let us do that. Okay, so this means each and everything has been done properly, and in case you want to test, then you can copy and paste this command and let me echo all the things like this. Okay, so that means all the things are has been configured properly. Okay, so let us move to the next part. I hope you guys are following me. Any problem till now, till this step? Any participant who is following me? Any problem? Okay, so I'll assume that the things are going smooth at your end. Now, in this section, we can make the use of the ROS packaging system and its associated tools. So for example, since we have already installed ROS, so we can make the use of this command to find any packages. ROS pack find ROS CPP. Okay, so if you type this one, then it will tell you where exactly the ROS CPP package has been located. Okay. Then you can use ROS CD to navigate to any particular package. So let's say ROS CD, ROS CPP. So if you want to go to that package, then you can make or you can use this particular command. Okay, so that way you will be inside that particular package. So these are some of the commands, very analogous to your Ubuntu commands and all, or Linux commands and all. So these are basic commands like present working directory and logs and all. So of course we can do that, and auto completion tab is also being supported. So these are basic ones. So you can just explore these commands. So I can see the Sanjan Kumar is saying that there's no problem installation. Good to have. So as you can see, if you are familiar with the working in Linux, then these are very analogous to CD and ls command. Okay. So in a typical Linux system, CD means it is used to change directory, and ls means to list the directories, right? So in ROS, it has been combined. So ROS ls is going to give you all the listing like this. Okay. And ROS CD will be used to navigate to a particular package in ROS. So let us go forward. Now let us try to create a package. Okay. So I have gone to the next one, which is creating a ROS package. So since we have already created a catkin package, right? Now it is time to move towards that package. So now we are using this CD command to move to that folder which we have created earlier. Okay. So for that, I have just copied and pasted this command. So now we are in that package. Now we can create one more folder named as beginner tutorials, and we can define the dependencies of it. Okay. So you first need to execute this command over here. So this is going to create, because I have already created this one, so that is why it is giving me the error. So when you will run for the first time, it will be done, no problem. Then you will need to make it. Okay, this command. Then you need to go into this. Then you need to make it. Okay, so the moment you are done with that, then you also need to add this particular workspace in your ROS environment. Only then you will be able to get the things regarding these packages with the auto completion command or other things. So I have just copied and pasted. This is a data just to ensure the conductivity. Okay. Now till now, I guess all the things are working fine. And of course, we can test few things like the dependencies which are associated with the ROS pack, which is ROS package. So like this one. So this time we have used this command to find out the first level dependencies for this particular package. Okay. So it is going to show the dependencies which are there. That means this thing has to be there, without which the functionality is not going to be. Okay, in short. And alternatively, you can see all the dependencies. Okay, this was the first level dependencies, and the dependence. For example, these are the packages. Okay, on which it was dependent, and again these packages may have other dependencies with them. Okay, so in order to find all the types of dependencies for all the packages and sub packages, you can use this particular command. So now we can see that number of dependent or dependencies have been shown, right? So this is the all dependencies for packages and sub packages. Now, again, the customization can be done from your end as per your need, like line numbers or descriptions and all. Okay, so that is nothing much about it. Now we are going to move to the next one. So you can see these beginner tutorials, right? So you can see this package XML, what exactly has been there, like this. So we'll get all the details, okay, here, the final package XML. So what are the dependencies, what is the version and all. So you can just see. So I guess all of you have followed me till this point. Now let us try to create our own package. This one. Okay. Now the important part of this is understanding the concept of ROS nodes. So already we have discussed these are the basic elementary building block, right? So now let us see how exactly this node functions in ROS. Okay. So since we have already installed this one, okay, so no problem. Second. Sudo install. It's already there, no problem. Okay. So now the important thing which we have to do is we need to start the ROS code. Okay, the central unit which is going to manage each and everything. So you have to come to this point number 5. Okay, so which we always need to start whenever we want to do anything in ROS. So ROS code. Fine. So I have typed it and then I have pressed enter. So this is going to start the master node. Okay, at this address, add this port number, and this is the process ID of that. Fine. So anyone who has installed this one or who have installed the ROS, they can type this command and can press enter and let me know whether it is working or not. Who installed ROS earlier? They just need to type this ROS command and press enter. Then they will end up to this page or these things will come. Anyone? Any participant can acknowledge this thing. They just need to type this ROS code after the installation and then press enter. So you will get these things. Any participant? Dharmesh sir, you can ask any participant if they are following me, so that
Sure. So participants, everyone, you can write in chat box.
okay. So I got the message from Srinidhi that they are able to run this ROS code. Okay, so I assume that after installation, when you type this one, it will get started. Okay. Now this is the one shell. Now you have to create a different shell for other things. So what you can do, you can type open terminal. Okay, so one new terminal will be opened. Alternatively, you can press Control Shift T. Right, Control Shift. Yeah. Control Shift T. So one new tab inside the same terminal will be opened. Okay, either you can open the new one or you can open the new tab inside that. Okay, so I'm going to open inside this one so that you can do with the help of Control Shift T button, that key. Okay, then yeah, so let us type this one and it will give us the list of all the present nodes. So since only one thing is working, which is ROS core, so that is why it is giving us the information regarding only one node, which is ROS out. Okay, so you can also see the information regarding this one. Okay, so it will give you all the information. What are the services available with that one, and what is subscription, publication, and the process ID and other things. So then let us go with the some solution thing. For that, we have command ROS run, which is going to run any node. Okay, and the node which we are going to run is turtle sim. Okay, and then turtle sim package, and then turtle sim node. Okay, so you need to type this command, so it will create a node like this. Now we are trying to understand the concept of robot operating system. So as have been explained earlier that we have got number of nodes and all the nodes are being managed by a central unit called as ROS core, right? And then it is based upon publish subscribe model. So the overall thing is how we are going to communicate with the robot. So all the communication do take place in the form of nodes. Now we are going to see how that publish subscribe model works. Okay, so now we have created a node. Fine. Now the next thing which we are going to do is we are going to find out the ROS node list now. Before initializing this one, only one node was there. Okay, now as you can see that now a script is running in this particular profile or in this particular shell. So I'm going to open one more tab in this terminal. Again, I'll press Control Shift T. Okay, so it will create one more shell or shell tab. Okay, so ROS node in this. So this time you can see now this node have also been listed, right? Okay, so now you can assign the name to this particular node. So anyway, this is a very basic thing, no problem. So I'm not going to do that. And you can check the status. Since we have not provided the name, so that is why it is giving the error. So we can name, no problem. So one more node has been created this time. And we need to again open one more tab. So this time now that turtle sim node has been renamed as my turtle, right? So now if you just copy and paste this pin command, then will be getting ping messages from the node. Okay, so that means the communication is being happening with the node. Okay, so now you can come out of it by pressing Control C. Okay, so I'll press Control C. So it will stop. Clear, just to clear all things. Then let us move towards the next. So as we have already started ROS course, so no need to start once again. And now we are going to run the TurtleSim node. Okay, means we are going to create one more node process, and with that node process, we'll be trying to communicate with this node. Okay, which is a turtle. So that will define the way with which the ROS function. So already one node has been created. Then you need to create another node by this. Okay, so it is going to run another node turtle teleop key, which is inside the TurtleSim package. Okay, so now that node has been initialized. So now what I am doing, I am pressing my arrow keys of keyboard. So you can see some movements are being observed, right here. And how I'm operating this one with the help of the keys of my keyboard. Okay. So it means whatever we have seen regarding ROS, which follows publish subscribe model. So here we are publishing some message, and this turtle bot was or has subscribed that message. So that is why it is getting that messages and following. Okay. So this way you can verify the working of the ROS, and we can also see the working. So it has got some inbuilt tools and libraries, as I told earlier. So we can run this one. ROS run. It will. Okay. So the moment you run this command, you are going to get this. So if you recall in the presentation, I have shown some of the diagrams, right? So these are the diagrams. So these are the two nodes, teleoperating turtle and my turtle, right? And this is the topic. So it is publishing some messages, and this node is subscribing these messages. Okay, based upon this particular topic. So you can see this. So the students who are following me, they can run it and they can see it working. So and of course these movements you can define with the help of some program. So as of now I am just typing it, or I am sending some messages to my keyboard, but you can write your own program and you can define all the linear angular movement of that TurtleSim robot. Okay, so it is up to us. So you can just follow these things and then you can run it. So if you guys need some time, then I can wait, no problem. Or you can just go through these topics, these commands one by one. So that way you will be able to run each and every command. Okay, but you need to follow the proper syntax and all. Okay. So what I have done over here, I have just send one predefined command. So this time I have not pressed the key. Rather, I have defined all the movement. Okay, what is going to be the linear movement, what is going to be angular movement, and what is going to be the angle and all. Okay, so all that have been defined. So x movement, y movement, and the angular movement, all the things have been defined. Okay, so I'm going to do it once again. Okay, then once again. So alternatively, you can define all the movements with the commands as well, or you can write in the form of a program. Okay, so these are some of the things regarding this one. So if you guys have got any doubt, then you can ask me. So there are a number of settings like hertz and all, and the movement which you can do. Okay, then of course some other things are also there. And if you are going to have some, if you want to play around some parameters which are already there in the ROS environment, then you can also change them. Okay, for example, the ROS services which are there, so you can use those services. Okay, for example, what are the type of services and what they do. So let me run one of the service. If I type ROS service call clear, okay, so just see this one, what is going to happen. So this way I have defined a service, or I have made a service, means I have made some request and then I got a response, right? So similarly, there are a number of services which we can run. So this one is to respond the another, this is type one. Okay, just type it. Okay, so all these are the services and these are the uh, parameters. Okay, or the arguments which are there and one can set. So alternatively, you can also type this one. So another spawn or another turtle scene has been placed in the simulation. Okay, and of course we have defined all the parameters, position parameters. Okay, where what is the x, what is the y, and which angle it has to be placed. So like that we have defined. So similarly, there are a number of things which one can do. Okay, and if you want to just have the current status, then you can also do that. Control C, then again. Okay, so if you got some other things, then you are going to also be observed here as well. So with this, would like to end the implementation part. So I believe unless you do it by yourself, you are not going to understand it. Okay, so in general, I can just give you the brief or can give you the confidence where you can start working with the ROS. However, it is just a tip of iceberg. But I believe if you are interested to work in the field of robotics, if you want to do some research, then these are the tools which you can consider for your work. So with this, I'm going to end the session from my side. In case you got any query, then please feel free to ask. So this is the implementation part, and you guys need to do it by yourself. Only then you will understand. So there are sir, you can ask from the participants if they have any query or any problem.
Anyway, sir, if you have some,
So your voice is breaking up.
your son step to install for ROS, if someone has missed to install, we will share this video recording so that they can do at home. No
Okay.
participants asking about this installation.
Okay. Okay. Just one question I have got in the chat box. Let me address that one. If I run Ubuntu through VirtualBox, then do I need to install ROS each time I launch? No, no need. Just one time installation you need to do. So once you have installed ROS, then no need to install it once again and again. It is just one time installation. So all the commands I have run for the sake of clarity so that you can know how to run those commands. So that is why I have run it. Since I have already installed it, so no problem. And I can just show you. Yes, for example, this is my virtual machine, and now what I'm doing, I'm just closing it. Okay, first I do Control C. By pressing Control C, you can stop working this ROS code. And if this ROS code has been stopped, then none of the command is going to work. Okay, so first this thing has to be started. So now I have closed it, so none of the things are going to work. So I'll just close all the things. Okay. Now I just so start once again. Any other participant who have got any other question? Because I believe the most difficult part is to start something. So once you feel some or you have some confidence and you start installing, or once you are done with the installation, then believe me, you will feel a lot more comfortable in this particular. So just let me start one. Okay, so just ROS. This time I have not installed it. Okay. This time to install, and then again I can run those things which I have just done. Okay. Yeah. So you can see this one has been now opened. Okay. Same thing again which I have done. I can control this robot like this. So in short, there is no need at all to install. Just it's a one-time installation. Okay. Yeah. Any other query, please? If someone have, I'll be happy to answer. It is a very very big thing. Even a separate course come to understand the ROS. So it will take some time. So with this, sir, I would like to end the session. If someone has got query, then we can ask. Otherwise, we can end the session. No problem. Because it needs practice from the participants. Sir, should I?
It was nice presentation, sir. You have shown a step-by-step procedure how to install ROS. I think no participants have any query. So we can conclude here, sir. So thank you, sir, for giving your valuable, for sharing your valuable information about ROS and installation, how we can install. Webots, how we can use the prototype and simulation for robots.
Okay.
So thank you, sir.
Thank you, sir. Thank you for inviting me. And
Thank you, sir, for joining the session.
Yeah.
Really, it was very informative session, sir.
Thank you, sir. Thank you. So I'll stop my screen share.
Yes, sir, you can stop your sharing screen.
Okay, sir. So I'm leaving now, and thank you once again.
Thank you, sir. Thank you. Participants, I have shared evening session attendance link, so you can fill this Google form. This is attendance as well as feedback form for session, third session. Morning session already we have shared. This is attendance and feedback form for evening session. And one announcement will be there for tomorrow class. So tomorrow we have yoga for physical and mental well-being session. This will be taken by yoga trainer. So it will start from morning 7:30 to 9:30. So morning 7:30 to 9:30, there will be yoga live yoga session by a yoga trainer. So I request all the participants to join the yoga session. So you can do yoga at home. So that's why we have scheduled in morning time. So this is third day's program. And morning 7:30 to 9:30 we have yoga class by Mrs. Poonam Awadhya. She is a yoga trainer. And then we'll have second session from 12 to 2 p.m. And third session will be from 3 to 5 by Vijay Kumar Dala. So I hope you'll join tomorrow morning session for yoga class. So this is live yoga session. So you can join from your home. If any participants would like to ask any question or query, if you have any query, you can raise your hand so that we can meet you. You can ask. And some participants are asking about, suppose they have missed the attendance to fill the Google form. So don't worry, we'll collect your attendance from WebEx login. So this is automatic attendance recording system. So where we generate the report. So don't worry, suppose you have missed the Google form, then we will collect your automatic attendance report, which is generated by Cisco WebEx. Okay. Yes, it's a local. Yes, you can unmute. I have sent you requests.
Sir, can we get the videos of day one? I just wanted Nandi sir's video, please.
Day one video I have shared through Google Classroom. So if you have joined, have you joined Google Classroom?
I'm having Google Classroom, but I'm not joined.
Okay, you have not joined. Okay. Then I will send you mail. So already I have shared day one video recorded session. So we had 3 sessions. So
I request you to send on the group also, sir, WhatsApp group if possible.
Okay. Otherwise, okay.
And kindly share me the Google Classroom link. I'll join, please.
Okay, ma'am, I will share.
Yeah. And also
Thank
share
you.
on the group, sir, WhatsApp group, please, videos.
Okay, ma'am. Sure.
Yeah.
Anyone? Any other participants would like to ask any question? So thank you for joining the session. So now we can close the session. So we'll meet tomorrow morning, 7:30 to 9:30 to attend the live yoga session by Poonam Awadhya ma'am. She is a yoga trainer. So we will end the program. Thank you for joining the session.